Alright, in this video we're going to be looking at hidden quadratics. You might sometimes hear these being referred to as disguised quadratics or quadratics in some function of x. Okay, so these are basically equations that don't look like quadratics but are in fact quadratics. So I've got three examples that we'll go through together. So the first one is x to the power 4 minus 7x squared minus 18 is equal to 0. So the highest power here in this equation is the power of 4. So this means what we have is a quartic function, but we can rewrite this as a quadratic because we know that a quadratic is any equation of the form ax squared plus bx plus c. So what we can do is write x to the power 4 in terms of x squared. So using laws of indices, this can be written as x squared, and then we put a 2 outside because these powers will then multiply. 2 times 2 still gives us our 4, so this is still x to the power 4 minus 7x squared minus 18 is equal to 0. And so what we can do here to show that it's in fact in the form ax squared plus bx plus c is to use a substitution. We can say let u equal x squared. So where there's an x squared, we're going to replace with u. So this becomes u, and then we've got this 2 outside squared minus 7x squared, so u minus 18 is equal to 0. So now you can see that this is in fact in the form ax squared plus bx plus c. So this is in fact a quadratic. And so at this point you can use whatever method you prefer to solve the quadratic. I will factorize. So we've got u, and we also have u here. We want factors of negative 18 that add up to give negative 7. So that's going to be negative 9 plus 2. Okay, so we get u plus 2 is equal to 0 and u minus 9 is equal to 0. So we get u is equal to negative 2 and u is equal to 9. But we're not done here because remember our original equation is in terms of x, so we want to solve for x and not u. So we can then reverse our substitution to go back to x. So this would become, instead of u is equal to negative 2, it becomes x squared is equal to negative 2 because u is equal to x squared. And then we also have x squared is equal to 9. Alright, so I'll just start with x squared is equal to 9. For x squared is equal to 9, we can take the square root on both sides, right? So square root of x squared and then plus or minus the square root of 9. And here we get that x is equal to plus or minus 3. And then if we look at x squared is equal to negative 2, we have a bit of a problem here. Because if you square any real number, you're not going to get a negative result. Okay? Because this would mean if we want to solve this, right, we take the square root on both sides and say that this is the square root of negative 2 plus or minus. We cannot take the square root of a negative number and get a real solution. So here we'd get x is equal to, we can say no solutions, but technically it's no real solutions. You will learn that this technically yields imaginary numbers when you get to pure 3 maths, but for now you can just simply say no solutions. But if you want to be more precise, say no real solutions. So the solutions that we get from here are your x is equal to plus or minus 3. Because we had x squared is equal to negative 2, we know that there's no real number that we can square and get a negative result. So that equation will yield no real solutions for us. Alright, so let's look at another example of a hidden quadratic. Say we've got 8x to the power 6 plus 215x cubed minus 27 is equal to 0. So to show that this is a hidden quadratic, we want to rewrite x to the power 6 in terms of x cubed. Again, the goal is to write this in the form ax squared plus bx plus c. So this becomes 8x cubed, and then we put a 2 outside because 3 times 2 still yields the 6 plus 215x cubed minus 27 is equal to 0. And then here we're going to use a substitution and say let u equal x cubed. So wherever there's an x cubed, we'll replace with a u. So this becomes 8u squared plus 215u minus 27 is equal to 0. And so we've shown that this is a quadratic. So at this point we can go ahead and solve this like you would solve any quadratic. Okay, so we can factorize this and say 8u, u here is equal to 0, and we can say positive 27 here and negative 1. 8u times 27u gives us 216u minus this u, which gives us 215u. Again, use whatever method you prefer to solve your quadratic. So here we're going to get 8u minus 1 equals 0, or u plus 27 is equal to 0. So from our first equation we get 8u is equal to 1, which leads to u is equal to 1 over 8. And then from our second equation we get that u is equal to negative 27. Now since we have found u, we can then use that to help us find x. Since our original equation was in terms of x, it means we're solving for x. So we're going to reverse our substitution and say that u is x cubed, so this means that x cubed is equal to 1 over 8, and x cubed is also equal to our negative 27. To get rid of the power 3, you have to take the third root. Alright, so take the third root on both sides. Here you're going to get that x is equal to, that's 1 over 2. And then here again we're going to take the third root on both sides. Third root, okay, and yeah, be careful, since this is the third root, it can actually take negative numbers. Unlike your square root or your fourth root, sixth root, your even roots do not take negative numbers, but your odd roots will take negative numbers. So the third root of negative 27, that's going to be negative 3. Alright, so these will be our two answers. Let's look at one more example together and then you can go through the quiz. So we've been given 6 root y plus 2 over root y minus 7 is equal to 0. It's very difficult to see that this is a hidden quadratic at first sight. So the first thing that you want to do when you have any equation and you're solving for some unknown, you want to get rid of any denominators that you have. So in this case, we can multiply through by the square root of y to get rid of our denominator here. So if we multiply the first term, 6 root y, by y, you're going to get 6y plus, here the root y will cancel out, so plus 2 minus 7 times root y is equal to 0. Okay, and so we've got, I'm just going to move this to come second after 6y minus 7 root y plus 2. Now we can rewrite the square root of y as a power using laws of indices. We know that square root can be written as the power 1 over 2. So it means what we have is 6y minus 7y to the power 1 over 2 plus 2 is equal to 0. And now what we want to do is we want to show that this is a quadratic, so it can be written in the form ax plus bx plus c. Alright, so to do that, rewrite y in terms of y to the power half. So that's going to be 6 times y to the half, and we're going to put the power 2 outside, because 2 times 1 over 2 gives us the power 1. Alright, and then we've got minus 7y to the half plus 2 is equal to 0. Then we're going to use a substitution to really show that this is indeed a quadratic. So let u equal to whatever we have in the bracket, y to the half. And so wherever there's a y to the half, you want to replace with u. So this becomes 6u squared minus 7u plus 2 is equal to 0. And this is in fact a quadratic. So let's go ahead and solve our quadratic. Alright, so we can do 3u here and then 2u here is equal to 0, and we want to do minus 2 minus 1 so that we get negative 3u, negative 4u, which is negative 7u. Alright, again, use whatever method you prefer for solving your quadratics. So we're going to get 3u minus 2, the first bracket, is equal to 0, or that the second bracket, 2u minus 1, is equal to 0. Alright, so this means 3u is equal to 2 and u is equal to 2 over 3. And then we're also going to get that 2u is equal to 1, so u is equal to 1 over 2. And now that we have found u, we need to then reverse our substitution so that we can find y. So this means y to the power half is equal to 2 over 3. And we also get that y to the power half is equal to 1 over 2. Alright, so to get rid of the power half, we have to raise both sides to the power 2, because the 2 will then cancel out the half. So you get that y is equal to 2 over 3 squared, which is going to be 4 over 9. And then in this case, we're going to do the same as well, square both sides. You get that y is equal to, that's going to be a quarter. And these would be your final answers. So this is how you deal with hidden quadratics or disguised quadratics. Now you will notice that there's one type of hidden quadratic we haven't looked at, which is the trig hidden quadratic. We're going to look at that under the trigonometry topic, so do not worry about that. Alright, so make sure to go through the quiz and I'll see you in the next video.